Hello everyone, welcome to the next lecture on the CSIR Net PY question series. Today I will explain you how you can find the resolvent kernel of the Volterra equation. I will explain this with the help of the fully shortcut tricks, and you can see after the end of this video you will learn many shortcut tricks. Myself Dr. Harish, you can simply follow my YouTube channel where you can find the various PY question series under the playlist CSR UGC Net. If you particularly watch my PY question of the integral equation, you can watch these first two lectures, that is again with the help of the shortcut tricks. Apart from them, if you are interested to find the PY questions of the integral equation, you can see these are the lectures which are available in this of the December 2023, December and June, and many more are available at this playlist. So let's start with this PY question series. So first of all, I will tell you what is the shortcut tricks and how you can apply the shortcut tricks so that you can solve each question within the help of the 10 to 15 second time period. I hope you can subscribe my YouTube channel as well. So whenever you will see any of the Volterra integral equations which is particular of the second kind, that means whenever the integration is from a to x, make sure it's a variable. It is not from a to b, it is from a to x. Then your target is to find the resolvent kernel, and you all know this is the formula for the resolvent kernel, where lambda is the eigenvalue, this is my lambda, and km you can identify as k1 is my initial kernel, this is my call-logic kernel, k2 I can identify from here, there is an integration from t to x and so on. But you can see after solving this you have to put up as a summation of this. It's a very lengthy procedure. Then what is my shortcut tricks for you? It's, remember that it is not available at any of the YouTube videos, but I will explain you my simplest approach. Firstly, look about this k. K is called as the kernel. Fine. And if you prove that these will satisfy these two properties, that is k of x comma x is my 1, k of x comma t and t of x is my 1, then there is no need to write this kernel in such a manner. You can write the kernel of the equation directly as k x comma t, whatever the given condition, into e raised to power lambda times x minus t. Make sure this lambda you can find as the coefficient of integration from a to x. A may be 0, a may be non-zero. Fine. So this is the simplest way I can tell you. You can solve this with the help of the 10 second. And once you can find the resolvent kernel, then you can find the solution of this problem by using fx plus lambda. Instead of the k, we can use as a resolvent kernel, and f is nothing, y is nothing but f of t. So let's see. Firstly, can you find the resolvent kernel? Firstly, check whether this property is satisfied. What is the k x comma x? It is a 1. First property satisfied. What is the tx into x comma t? So clearly say, when you substitute, what is a t comma x is a 2 plus cos t divided by 2 plus cos x, and it is 2 plus cos x over 2 plus cos t. So clearly say it is a 1. Now once both the properties are satisfied, then your kernel will be whatever the given function. So that means your kernel of this is my 2 plus cos x divided by 2 plus cos into t. What is the lambda? Lambda is given as a lambda times x minus t is the right answer. Fine. Look at this second one. Again clearly say these two properties are satisfied. X comma x is my 1. Fine. And t comma x into x comma t is my 1. So what is the resolvent kernel? So resolvent kernel R is kxt into lambda times x minus t is the right answer. You can see how many seconds you are needed to find the resolvent kernel. Similarly, look at that. If your kernel x comma t is e raised to power x minus t, then clearly say x comma x is my 1, because e raised to power 0 is 1. Then what is the x comma t and t comma x? So clearly say this value will be x comma t, x minus t, and it is my t minus x. Clearly say this is e raised to power 0 is 1. So all those properties satisfied. So resolvent kernel will be e raised to power x minus t into lambda times x minus t, or you can simplify this. This will be 1 plus lambda times x minus t is the right answer. Similarly, you can verify for this last case. What is that? Kernel is my here. Clearly say k of x comma x is my 1, satisfied. Second property is also satisfied. So what is the resolvent kernel for the last case? 1 plus x square 1 plus t square into e raised to power x minus is the right answer of this problem. Now let's start with this first question. What is that? 2. Lambda is given as a 2. Make sure it is written as phi of x. It is always be written in the standard form. Fine. Y is equal to fx plus here. So lambda is my 2. What is my kernel? X comma t or x comma xi is e raised to power x minus. Fine. Does it satisfy both the properties? X comma x 1. Fine. What is the x comma xi and xi comma x? Clearly say it is also 1. So it means it satisfied all these properties. So what is the resolvent kernel? It's a given function x minus xi. What is the lambda? Lambda is 2x minus xi. So what is the answer of this? 3 times x minus xi. So that's a C is my right answer of this problem. I hope you can simply learn that. I can say you can request. I can say you can like my video as well. Don't forget to subscribe my YouTube channel. The resolvent kernel integration is from a to x. What is the lambda? Lambda is nothing but lambda. What is the kernel? What is the x comma t? This is my 1. The coefficient of this is 1. And clearly say it satisfied all these properties. So then what is the resolvent kernel? 1 into e raised to power lambda times x minus t is the, where is the answer? Lambda times x minus t is the right answer. It is a product, it's a wrong, it's a plus wrong, so the right answer is B is my correct answer. Okay, look at this one. Again, it's a Volterra equations from 0 to x. What is the lambda? Lambda is my 1. Fine. But you can see here, it is a t minus x. Make sure you're firstly, in this case, it is my t minus x. Make sure whenever you are defining the kernel, it should be in the form of x minus t. Coefficient of the x must be positive. So I can make it as firstly positive. Fine. Now this is my kernel. Fine. Now you can verify all those two properties on this equation. So what is the k of x comma x? It is 1. K of x comma t into k of t comma x. Again you can see this number is minus x plus t. It is minus of t plus x, which is 1. So all those properties satisfied. So what is the resolvent kernel? E raised to power this function. Make sure coefficient of x should be the positive thing. Fine. Into lambda is my 1 into x minus t. So what is the answer of this? It will be cancelled out. So the right answer is 1 is my right answer. Make sure the coefficient of the x you have to put in the positive sign, whatever the sign of this here. Okay, again the integration is from the 0 to x. Make sure again this rule is applicable only from the 0 to x or a to x, not from 0 to 1 or 0 to 2 and so on. What is the kernel is? 2 raised to power x minus t. So x is my positive. Fine. Now you can see, is it satisfied all these properties? Yes, clearly say x comma x is my 1. Fine. And x comma t and t comma x, which is also 1. So what is my resolvent kernel? 2 raised to power x minus t. What is the lambda? If you compare them, the coefficient of this is my 1. Lambda is my 1. 1 into x minus t. Fine. That is this is called as resolvent kernel. But if you look at the statement, they are talking about the iterative kernel. That's very simple. What is the iterative relation between the iterative kernels and the resolvent kernel? So if I am talking about the K3, that is a similar of this, you have to write this quantity. Fine. Write this, you have to expand this series with the n minus 1 over n minus 1 factorial. Fine. So this is x minus whatever the coefficient of this, it should be here. Now you need a k3. Fine. So k3 n will be 3. So what is the right answer? X minus t 3 minus 1 over, so this I can written as, this is a square, so it's a cube, cancel out, it's a cube, cancel out. It is a divided by 2, it is a minus of 1, and it is here. C is my right answer of this problem. Fine. Now if for example, if somebody will ask you find the K2 iterative kernel of this, so whatever the expression of this, so that means if the power is x minus n minus 1 over n minus 1. If somebody will ask you find the iterative kernel of this, say for example K2, what is the expression of this resolvent kernel is 1. So there is a single 1, so it is also be a 1. Now you can see this is the December 2023. Again from the 0 to x. Does it satisfy all those properties? Firstly, what is the lambda? Lambda is my 1. Does it satisfy? K of x comma x is 1, fine. T comma x and x comma product is also 1. So what is the resolvent kernel? It is 1 plus x square, 1 plus t square, e raised to power lambda is my 1 into x minus t. But right now they are talking about the solution. So therefore, what is my solution? Solution is y, which is equal to e raised to power x plus integration of this resolvent function 1 plus x square over 1 plus t square into e raised to power x minus t into f of t. This is my fx. Fine. So what is f of t? E raised to power t. Now you can solve that. E raised to power x, integration with respect to x. So I can take e raised to power x common, 1 plus x square common. So this value will be cancelled out. The integration of 1 over 1 plus t square, that means tan inverse t. Tan inverse t from the lower limit and upper limit is tan inverse 0. Fine. Now you can substitute y of 1. What is the y of 1? E raised to power 1 is common. 1 plus 1 2. Tan inverse 1 is pi by 4. So right answer is pi by 2. This is wrong. Root 3. What is the value of the y of root 3? E raised to power root 3 is common. It is a 1 plus 1 plus 3 is a 4. Tan inverse root 3, that's a 60 degree, pi by 3. So 1 plus 4 pi by 3 is the right answer. B and D are my correct answer. And you can see how many seconds you are needed. A fraction of second you are needed to solve the problem. Okay, look at that. Now they are talking about the integral. Find the solution of this. Again from the 0 to x. This is my kernel. Does it satisfy all those properties? Yes, because x comma x is, it will be cancelled out 1, and t comma x and x comma t is 1 also. So it satisfied all those properties. What is my lambda? It is 1. So what is the resolvent kernel? Resolvent kernel will be 2 plus cos x divided by 2 plus cos e raised to power lambda is 1 x minus t. Now your solution will be y of x e raised to power x sin x plus 0 to x, this function, to this r, 2 plus cos e raised to power x minus t into f of t. What is the f of t? This is my fx. What is the f of t? Is e raised to power t sin of t into dt. Make sure the solution will be whatever the function fx plus integration resolvent kernel into f of t. Fine. Now you can see I have to integrate with respect to x. So with respect to t, so e raised to power x common, 2 plus cos x is common. The inside term is 0 to x. This will be cancelled out. So that is a sine of t divided by 2 plus cos of t. It is e raised to power x sine x. Fine. So what is the answer of this? E raised to power x sine x plus e raised to power x 2 plus cos x. What is the integration of this? If I substitute this as a q, then the derivative of this is a minus log of 2 plus cos of t from 0 to x. Now you can substitute the lower limit and upper limit, you will get the right answer of this problem. Okay, look at this one. Again, your target is to find the solution. This is my kernel. Does it satisfy both the properties? Yes, k of x comma x is 1 and t and x both are my 1. So what is the resolvent kernel? 1 plus x square, 1 plus, what is the lambda? Lambda is my 1. So into e raised to power x minus t. So therefore, the solution will be fx plus integration from 0 to x r 1 plus x square over 1 plus e raised to power x minus into f of t. F of t will be 1 plus t square. Fine. Now you can integrate them. I have to integrate with respect to t. So e raised to power x common, 1 plus x square common. So right, the left thing is this value will be cancelled out, e raised to power minus t. Now what is the answer of this? 1 plus x square, I can put them as a common, 1 plus e of x. What is the integration of this? E raised to power minus t over minus 1 from 0 to x. So that will be 1 plus x square. If you substitute the lower limit, it will be my 1. So that is a 1 is a minus 1. If you substitute 0, it is my 1 into e raised to power x. So 1 and 1 will be cancelled out. So the right answer is e raised to power x. 1 plus x square will be the right answer. Okay, look at this another one. Again, it's a 0 to x. Lambda is my lambda. Fine. Kernel is my e raised to power x minus t. Does it satisfy all these properties? Yes. K of x comma x is my 1. T and x is my 1. So what is the resolvent kernel? This is this. What is the lambda is? Lambda is my here and of this. Make always sure it is in the form of the x minus t. So this is 1 plus lambda times x minus t. So what is my solution? Y of x is, because f is unknown to us, so I have to written in the terms of the f, that is the resolvent kernel, this x minus t into f of t. Because f is my unknown, so you can never integrate them, so you can better simplify this is 1 plus lambda times x from 0 to x minus 1 plus lambda times t. That is the right answer of this problem. Again, look at this another one. Lambda is given as a 2, x is a positive, so k is my x minus e raised to power x minus t. Does it satisfy all properties? Yes, it's satisfied. So the resolvent kernel will be x minus t, e raised to power lambda, x minus, so that means e raised to power 3x minus 3t. So the solution will be y of x sin x plus twice 0 to x e raised to power 3x minus 3t into f of t. What is f of t? Is my sine of t of dt. Now I can write this component as 2 e raised to power 3x is outside, e raised to power minus 3t sine of t of dt. Fine. Now this is sine x plus 2 e raised to power 3x. What is the integration of this? So we all know e raised to power ax sine bx of dx. What is the integration of this? E raised to power ax divided by a square plus b square into a sin bx minus b cos bx. Fine. Now you can substitute here. A is my minus of 3, so e raised to power minus 3. B is my 1, so 9 plus 1 10. A is my minus 3 sine minus b will be my 1, a, b and here, so it will be cos b into t, that is a 1 from 0 to x. Now you can substitute this value, upper limit and lower limit, you will get the right answer of this problem. This is 1 into t. Okay, look at this another one. Again it's from the 0 to x. Lambda is my 1. What is the kernel is? 1. Clearly say it satisfied all these properties. So the resolvent kernel will be 1 into lambda is my 1, x minus t. So the solution will be y of x is 1 plus 0 to x 1 e raised to power x minus t into f of t. This is my fx, f of t is my 1. So I can integrate them with respect to x. E raised to power x will be outside. This is e raised to power minus t. So that is 1 plus, it will be e raised to power minus t over minus 1 from 0 to x. So it is 1 plus e raised to power x, e raised to power minus x over minus 1, minus minus plus 1. So you can open this bracket. It will be 1 minus 1 will be cancelled out. E raised to power x is the solution of this problem. So that means y is equal to e raised to power x is the solution of this problem. You can see that a very simple and the unique approach you can find always on my YouTube channel. I hope you can subscribe, you can comment and like on my video as well. We will see the next lecture on the resolvent kernel of the Fredmode integral equation, again with the help of the fully shortcut tricks. You can scan and join my WhatsApp group if you are interested to join with me. Thank you very much, students. Best of luck, students. Happy learning.